Hello everyone, this is the first video we'll be doing on the AP Precalculus curriculum. It's the new AP class that College Board has released. So for you new students who are coming into this new class, I want to help you guys. And if you guys want to see any references or any materials that could help you with these classes, I'd recommend checking out the AP Precalculus course and exam description. I will link it in the description for those who want to see it. It isn't as comprehensive, but it does give a good outline of what you need to know for the exam. And in my videos particularly, I'll just be kind of combining a couple of topics together just so I don't have any redundancy with what I am talking about. So if that's it, let's get to it. Now the first unit pertains to polynomials and rational functions, and I already have a video on rational functions, though it was released before I decided to start doing these AP Precalculus videos. But you can still check them out. I might perhaps make another rational function video that's more fine-tuned towards the AP Precalculus curriculum. But for now, it'll just be polynomials. So let's get to it. The first thing we have to learn about are functions. So what is a function? A function is basically a mathematical relation, or something that you can put an input in and you get an output out of it. So if I have a function, say f of x equals x squared, okay, basic quadratic function, and if we were to input, say, f of 1, right, then we'd get 1 squared, which equals 1. Similarly, if I did f of 2 equals 2 squared, we'd get 4. Okay, these are functions. Now you can graph them. If you have a Cartesian plane, which is basically xy axis perpendicular to each other, and the inputs are the x-axis while the outputs are the y-axis, then we can graph the function. So for example, if we have this input which we said is 1 and the output is also 1, then we can just pinpoint that the point will be somewhere around here. Let me change this to another color so it's more visible. 1 second. So we have a dot right there. Now 2, 2, so we go over 2 up by 2. Okay, and we can continue this on. I'm sure I don't need to because you get the idea, but it gets steeper and steeper as we increase. So at 3 it would be 9. And the thing about quadratics is that if you put a negative, it'll still come out as positive because you're squaring the input. So then if I were to graph this out, it would look something like this, and it does touch the origin. The origin is 0, 0. So this is a very crude drawing of a quadratic function. We also have linear functions, and they're exactly what it sounds like. It's a line, basically. And how to denote that, the parent function is what I mean to say, is basically f of x equals x. And so that means that it's a direct relationship. Whatever you input in is what you're going to get out. Okay, so if I put in a 1 into this, you'll get out 1. If I put in a 2 into this, you'll get out 2. Our input into this is what I'm going to get out of it. So if I were to draw this out, and I'll do it in a different color so it's more seeable, I'll put in that. It'll just be a nice straight line like that that passes through the origin. Okay. Next, what we have to talk about are slopes. Now, slopes, aka rates of change. So rates of change is basically a depiction of how steep the graph is. And this is especially easy for linear functions because I'm sure you've seen this, I guess a formula. I'm sure you've seen this before. You've seen y, sorry, 1 second. I'm sure you've seen the famous y equals mx plus b, where m, that is your rate of change, right? ROC, rate of change, and this is your b is your y-intercept. Now your rate of change is basically how steep your graph is. Now this is especially easy for linear functions because the rate of change is constant. Whatever 2 points you pick, Okay, and this is how you calculate it. Whatever 2 points you pick, if I pick this point here and I pick this point here, what I'm looking at is what is the difference in the vertical distance between these 2 points divided by the horizontal distance between these 2 points. That is your rate of change, aka m equals your rise over your run. Okay, now in more mathematical terms, what do we say is y2 minus y1 over x2 minus x1, where this would be y2, or this can also be y2. It doesn't matter which one you choose as long as you're consistent with what you're subtracting it from. So, and this is what I mean by the rate of change being constant, because I can also choose these 2 points. These 2 points, and if I calculate the rise over run, it's still going to be proportionate to this as well. Now here's where the problem comes into play with quadratics. Quadratics do not have a concrete rate of change, because as you move towards larger and larger x values, the steepness of the graph becomes larger, which means that as you go to the right, the slope of the graph increases. And so that means that we can't really represent it with a very concrete number as we can with a linear function. So here we have a function, okay? It's a simple linear function, f of x equals 3x plus 1. Now, let's model, now this function models an actual, say, real life situation. So let's say that you get a new job, okay? And your salary is $3 per hour, and it's not that good of a job if it's $3 per hour, but that's your salary. And to kind of, how should I say, to reward you for actually joining the company decides to give you $1 just right at the start. So let's say that if it's $3 per hour, how much money would you earn after you work, say, 12 hours? Okay, so we can do that if we input f of 12 equals 3 times 12 plus 1. Okay, and we can calculate that to get 3 times 12 is 36. 36 plus 1 is $37. That is your answer. After working 12 hours, you'll get $37. Now, this is easy because the rate of change, we've been given the rate of change because it's the coefficient of x. Now, what if I were to give you 2 instances in time, let's say at, I'll give an example. Let's say if I were to give you these 2 occurrences. So after working 10 hours, you earned $66, and after working 8 hours, you earned $40. So then what is your rate of change? And if you remember, it's the rise over run, aka y2 minus y1 over x2 minus x1. So let's say this is y2, and this is x2, and this is y1, while this is x1. Okay, so if we substitute that in, we get 66 minus 40 over 10 minus 8. Okay, simplifying that, we get 26 over 2, which can all be simplified to 13. That is your rate of change, $13 per hour in this scenario. Now, what if you were asked to fully model this function as a linear function? So we already have the slope, right? Remember, y equals mx plus b. We figured out m. But we still don't know b. What is b? B is your y-intercept, which means that when x equals 0, just nothing, right? Just at the start, what is your function equal to? And it's rather simple to do so when you already have your slope. So to figure out the y-intercept, let's first of all plug this into the y equals mx plus b scenario. Not scenario, but situation. Not situation, but you get the idea of formula. It's not a formula either, but... Alright, so we now have y equals 3x plus b. We're trying to figure out b, and this is not a 3, this is a 13, my bad. So 13x plus b, 13x. So now what we would do is we would pick one of these numbers. It doesn't matter which one you choose one. I'll choose 8 and 40. So 40 is the outcome, right? So we're going to put 40 on the left side of the equal sign, times that by 13 times 8 plus b. Okay, now we got 40 equals, what is 13 times 8? That'll be 104. 104 plus b. Great. Now we subtract 104 from both sides to get b equal to negative 64, or negative 64, yes. So negative 64 is our answer right there. So that is our y-intercept. So that means that just not working, you have negative $64, which doesn't really make sense in this scenario, since why would you be in debt for joining a company, but this company does. But I hope you get the idea on how to solve for the y-intercept. And this right here would be some mismatched representation of the function. But it's close enough because the y-intercept is negative, so I put it down here. And the slope is positive, so it's increasing, meaning that as you go from left to right, the slope is going upwards, okay? Because it's a positive slope. And basically, the larger m becomes, the more steeper the slope becomes, meaning that the more vertical it becomes, in a sense. It becomes much, much more vertical. Whereas the more horizontal it gets, the slope decreases, basically. The slope is a lesser number compared to 13 in this case. Alright guys, with that will be the end of this video. If you are new to AP Precalculus, or if you're learning for this for the first time, I hope you learned something. But if you're not, if you already knew some of this stuff, I hope that was a good refresher for you instead. I think that's it from me today. If you guys have any questions, ask in the comments. Make sure to like and subscribe. And if nothing else, I'll see you next time. Bye.